National Electrical Code Section 312.5c addresses the use of flexible metal conduit in specific environments. This section specifically prohibits the use of flexible metal conduit in wet locations or where it is subject to severe physical damage. The context of this code section is important. It's directly applicable to situations where electrical wiring methods, such as Romex, are being protected by conduit as they exit an electrical panel. The question at hand involves using electrical metallic tubing which, while not explicitly flexible metal conduit, is being considered for a similar protective purpose for Romex as it exits the bottom of an electrical panel. The code's intent is to prevent situations where the conduit itself could become compromised, either through environmental factors like moisture, leading to corrosion, or through physical impacts that could damage the conduit and consequently the wiring within. The exception that exists for conduit used out of the top of a panel is based on the rationale that such installations are generally less exposed to moisture and physical damage compared to those exiting the bottom. The bottom of an electrical panel is typically closer to the floor, making it more susceptible to water accumulation and physical impact. The code's requirement for alternative protection methods stems from the need to ensure the long-term reliability and safety of the electrical installation. Using a box and junction at the end of the conduit provides a secure and dry environment for making electrical connections, minimizing the risk of short circuits or ground faults. Therefore, adhering to 312.5c necessitates exploring alternative wiring methods or protection strategies that comply with the NEC safety standards. When considering wiring methods and protection for electrical systems, firstly, understand the specific requirements outlined in the National Electrical Code (NEC). Secondly, assess the environmental conditions and potential physical hazards present at the installation location. Thirdly, select wiring methods and protection strategies that are appropriate for the application and compliant with the NEC. In the specific scenario of protecting Romex wiring exiting the bottom of an electrical panel, Code Section 312.5c of the National Electrical Code comes into play. This section restricts the use of flexible metal conduit in wet locations or where subject to severe physical damage. Since EMT, electrical metallic tubing, is being considered for a similar purpose, the implications of this code section need to be examined. The primary reason for this restriction is to prevent the deterioration of the conduit and the wiring it protects due to environmental factors or physical impacts. When conduit is exposed to moisture, it can corrode over time, compromising its structural integrity and potentially damaging the wiring within. Similarly, physical impacts can dent or break the conduit, exposing the wiring to damage or creating a safety hazard. The exception for conduit used out of the top of the panel is based on the assumption that such installations are less likely to be exposed to moisture and physical damage. However, since the EMT in question would be used out of the bottom of the panel, this exception does not apply. The NEC mandates the use of alternative protection methods to ensure the safety and reliability of the electrical installation. One common alternative is to use a junction box at the end of the conduit to transition to a different wiring method. This provides a secure and dry enclosure for making electrical connections, minimizing the risk of short circuits or ground faults. Another option is to use a different type of conduit that is specifically designed for wet locations or areas subject to physical damage. For example, rigid metal conduit or PVC conduit may be suitable alternatives in certain applications. When selecting a wiring method and protection strategy, it's crucial to consider the specific environmental conditions and potential hazards present at the installation location. Factors such as moisture levels, temperature variations, and exposure to physical impact should all be taken into account. Additionally, it's important to consult with a qualified electrician or electrical inspector to ensure that the installation complies with all applicable codes and regulations. By carefully considering these factors, it's possible to design an electrical system that is both safe and reliable. In summary, using EMT for protection of Romex as it comes out of the bottom of a panel would indeed violate 312.5c of the National Electrical Code. This code section prohibits the use of flexible metal conduit in wet locations or where subject to severe physical damage. since the EMT in this case would be exposed to moisture and potential physical damage as it passes through the floor. The exception for conduit used out of the top of the panel does not apply. Therefore, you would need to use a different method of protection for the Romex, such as the box and junction at the end of the conduit. Let's delve deeper into the NEC requirements and explore alternative solutions for protecting Romex wiring. The NEC, or National Electrical Code, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, NFPA, and serves as the basis for electrical codes in most jurisdictions throughout the United States. Adhering to the NEC is crucial for ensuring the safety of people and property, as well as preventing electrical hazards such as fires and shocks. When it comes to wiring methods, the NEC specifies the types of wiring allowed in different applications, as well as the installation requirements for each type. Romex, also known as non-metallic sheath cable, is a common type of wiring used in residential and light commercial buildings. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Romex is typically used for branch circuits that supply power to lights, receptacles, and appliances. However, Romex is not suitable for all applications. It is not allowed in wet locations such as bathrooms and kitchens unless it is specifically listed for such use. It is also not allowed in areas subject to physical damage such as unfinished basements and garages. In these locations, the NEC requires the use of a different wiring method, such as conduit. Conduit is a rigid or flexible tube that is used to enclose and protect electrical wiring. There are several different types of conduit available, each with its own advantages and disadvantages. The electrical metallic tubing (EMT) is a thin-walled metal conduit that is commonly used in dry locations. It is relatively inexpensive and easy to install, but it is not suitable for wet locations or areas subject to physical damage. Rigid metal conduit (RMC) is a thick-walled metal conduit that is suitable for both wet and dry locations. It is more expensive and difficult to install than EMT, but it provides superior protection for the wiring. PVC conduit is a non-metallic conduit that is resistant to moisture and corrosion. It is commonly used in underground applications and in areas where chemicals are present. When selecting a conduit for a particular application, it is important to consider the environmental conditions, the type of wiring being protected, and the applicable NEC requirements. In the case of protecting Romex wiring exiting the bottom of an electrical panel, the NEC requires the use of a conduit that is suitable for wet locations and areas subject to physical damage. As mentioned earlier, 312.5c prohibits the use of flexible metal conduit in these locations. Therefore, EMT is not an acceptable option. Instead, you would need to use a different type of conduit, such as rigid metal conduit or PVC conduit. Alternatively, you could use a junction box at the end of the conduit to transition to a different wiring method. This would allow you to use Romex for the remainder of the circuit while still providing adequate protection for the wiring exiting the panel. The junction box should be located in a dry location and should be accessible for maintenance and repairs. When installing conduit, it is important to follow the manufacturer's instructions and the applicable NEC requirements. Conduit should be securely supported and properly grounded to prevent electrical hazards. Additionally, all conduit fittings should be properly tightened to ensure a watertight seal. By following these guidelines, you can ensure that the conduit provides adequate protection for the wiring and that the electrical system is safe and reliable. Let's consider some real-world scenarios to illustrate the application of NEC 312.5c. Firstly, imagine a residential electrical panel located in a basement that is prone to flooding. In this scenario, using EMT to protect Romex wiring exiting the bottom of the panel would be a clear violation of 312.5c. The EMT would be exposed to moisture during floods, leading to corrosion and potential damage to the wiring. In this case, a more suitable option would be to use rigid metal conduit or PVC conduit, which are designed to withstand wet conditions. Alternatively, the electrical panel could be relocated to a higher location that is not subject to flooding. Secondly, consider a commercial building where the electrical panel is located in a mechanical room. In this room, there is a risk of pipes leaking or equipment being damaged, which could expose the EMT to physical damage. In this scenario, using EMT to protect Romex wiring exiting the bottom of the panel would also be a violation of 312.5C. A better option would be to use rigid metal conduit or to install a barrier to protect the EMT from physical damage. Thirdly, imagine an outdoor application where the electrical panel is mounted on the side of a building. In this case, the EMT would be exposed to rain, snow, and other weather elements. This would make it susceptible to corrosion and damage. Therefore, using EMT to protect Romex wiring exiting the bottom of the panel would not be appropriate. Instead, a weatherproof enclosure and a suitable conduit type, such as PVC conduit, should be used to protect the wiring. In each of these scenarios, it is important to carefully assess the environmental conditions and potential hazards present at the installation location. Based on this assessment, the appropriate wiring method and protection strategy should be selected to ensure the safety and reliability of the electrical system. Consulting with a qualified electrician or electrical inspector is always recommended to ensure compliance with the NEC and other applicable codes and regulations. Let's talk more about the implications of violating NEC 312.5C and the potential consequences. Violating NEC 312.5C can have serious consequences, ranging from minor inconveniences to life-threatening hazards. Firstly, it can lead to electrical failures. If the EMT corrodes or is damaged, it can expose the wiring to moisture or physical damage, which can cause short circuits, ground faults, and other electrical failures. These failures can disrupt power to essential equipment and appliances, causing inconvenience and potentially leading to financial losses. Secondly, it can create fire hazards. Short circuits and ground faults can generate heat, which can ignite nearby combustible materials. This can lead to a fire that can spread quickly and cause significant damage to property and endanger lives. Thirdly, it can result in electrical shocks. If the wiring is exposed due to damaged or corroded EMT, it can create a shock hazard. Contact with live wires can cause severe injuries, including burns, cardiac arrest, and death. Fourthly, it can void insurance coverage. If an electrical fire or other incident occurs due to a code violation, the insurance company may deny coverage. This can leave the property owner responsible for all the damages and expenses. Fifthly, it can result in legal penalties. Violating the NEC can result in fines, lawsuits, and other legal penalties. In some cases, it can even lead to criminal charges. In addition to these direct consequences, violating NEC 312.5C can also damage the reputation of the electrician or contractor responsible for the installation. It can erode trust with customers and make it difficult to obtain future work. Therefore, it is essential to take the NEC seriously and to ensure that all electrical installations comply with the applicable codes and regulations. Consulting with a qualified electrician or electrical inspector is always recommended to avoid costly mistakes and to ensure the safety of people and property. In summary, using EMT for protection of Romex as it comes out of the bottom of a panel would violate 312.5C of the National Electrical Code. The best course of action is to explore alternative methods of protection for the Romex, such as a box and junction at the end of the conduit, or a different type of conduit altogether.